Alright, so we were talking about this example, talking about coffee and looking at coffee type versus strength. And so what are the levels of the experiment? The levels are basically the different levels of the variable. So for coffee type, we have two different, okay, we have two different levels. We have Starbucks and Peet's. And then when we look at the strength, how we break down the strength of the variable, we have the half a scoop, the full scoop, and 1.5 scoops. So then total, how many treatments are there? How many different cups of coffee could people try? When we look up there, we have 6. Okay, 2 coffee types and then 3 different strengths gives us 6. And is there a placebo treatment in this? No, no one's getting like a fake cup of coffee or something, some other brand to trick people. So there's no placebo in this kind of example. Okay, so principles of experimental design. Basically, one of the main things you want to do is control the effects of lurking variables. On the response, most simply by comparing 2 or more treatments. So control the effects of lurking variables, that's the main thing. Replicate each treatment on many units to reduce chance variation. And the results, so example, you don't want to just randomly assign one person to a treatment and get their result, because if they were some sort of anomaly where, whatever you're looking into, they either had really good results, really bad results, maybe just average, you need to do this multiple times so that you're getting what the tendency would be for all people, not just that one particular person. Okay, so replication helps to show whether any systematic differences in responses were due to the treatments. Okay, so we always want to showing that. Or due to the natural variability in the units. Systematic differences among groups of experimental units in a comparative experiment cause bias. Okay, so systematic differences among the groups, somehow something's influencing, their responses or how they're reacting, and so it's introducing bias into your experiment. Randomize, you also want to use impersonal chance to assign experimental units to treatments. Okay, so this is going to come up over and over again, the 3 principles of experimental design. So you're going to want to highlight this or star it. Control for lurking variables, replicate, so do it many times, and then randomize. We want to include all of those things whenever we do a good experiment. All right, example 16, gastric freezing is a clever treatment for ulcers in the upper intestine. The patient swallows a deflated balloon with tubes attached, and then a refrigerated liquid is pumped through the balloon for an hour. The idea is that cooling the stomach will reduce its production of acid and so relieve ulcers. An experiment reported in the Journal of American Medical Association showed that gastric freezing did reduce acid production and relieve ulcer pain. Treatment was safe and easy, but this was a poorly designed experiment. The patient's response may have been due to the placebo effect. Many patients responded positively to any treatment, whether it was a placebo or a drug. A later experiment divided patients into 2 groups, one that had a placebo and one that received treatment of gastric freezing. Researchers found that 34% of the 82 patients in the treatment group improved, and 38% of the 78 placebo patients also improved. This shows that gastric freezing was no better than a placebo, and it has now been abandoned. Its use has been abandoned. So again, the placebo effect is very powerful. on thinking that you are going in to be cured or to help your pain relief. And so by having any type of procedure done, you think that you should be getting better, and so mentally you're able to just control your pain levels and reduce them. So you can see that here, 38% of the placebo, which is even higher than 34% of the patients who actually received the treatment, felt improvement. So the placebo effect is something that happens a lot, and we need to account for that. Okay, so what we're going to talk about now is looking at how we're actually going to carry out different types of experiments. Okay, so again, more vocabulary. I would definitely suggest making flashcards. You just have to know these different types of experiments. And again, the last page of your notes is the list of all the vocabulary that's been within the notes, but you need to make sure that you know the vocabulary. So first off, a completely randomized design is when all the experimental units are allocated at random among all treatments. And so we're going to go through examples of all of these, in a minute. But just completely randomized design is where you take all the people in your sample and you're just randomly going to assign them to one of the treatments, and that's it. Okay. For a block design, it's a group of experimental units or subjects that are known before the experiment to be similar in some way that is expected to systematically affect the response to the treatments. So, for example, if we were doing a study and I thought gender was going to be an influence on how people responded to some sort of question or experiment, I might separate guys versus girls, and then now that they're separated, we knew that characteristic about them, their gender, then carry out the experiment where you randomly assign one of them, some of the guys to the treatment, some of the guys to the placebo. You do the same thing for the girls. The girls you assign to a treatment, and the girls you assign to a placebo. Yeah, so we'll talk about this more in a minute. Block design is a random assignment of units to treatments is carried out separately within each block. So the block design and a block kind of go together. The block is just the group of people who are similar, and the block design is where you actually randomly assign them to treatments. A matched pairs design is a type of block design, so it's very specific type of block design. It compares two treatments, only two. The subjects are matched in pairs. Sometimes each subject receives both treatments in a random order, and sometimes one subject in each pair receives one treatment and the other subject receives the other treatment. And we'll talk about this some more. A double-blind experiment. Neither the subject nor those who measure the response variable know which treatment a subject received. Okay, so somehow they do have to keep track of it. So example, if you are looking at, I've talked about earlier, looking at if calcium reduces blood pressure. So the people who are carrying out this experiment, you shouldn't know, the person who's taking the pill, the calcium or the calcium level or placebo, shouldn't know what type they have. So that's a blind study. Double blind means that also the person who's measuring the response, so taking their blood pressure, they're actually the ones who are monitoring it and calculating it and taking their blood pressure, don't know which treatment they had either. Because as humans, if you knew which treatment they had, you may be likely to round up or round down, just almost even subconsciously, to help the study. And so it's important also sometimes that the people who are actually gathering the data also don't know. It should be recorded, by someone, maybe by a certain number, or you keeping track of still whose blood pressure is, increasing or decreasing. It should all be recorded so that you can tell the difference when you go and look at the overall data. But just the person who's actually conducting, like taking the blood pressure in this example, shouldn't know. So that's double blind. Lack of realism is the subjects or treatments or setting an experiment may not realistically duplicate conditions we really want to study. This is most serious potential weakness in experiments. So sometimes we separate people and carry out experiments that wouldn't necessarily happen in real life, that just happens, we've separated it so much that it's not necessarily going to be replicated when people are just taking like a medication, for example. Okay, so example 17. Does taking, I think it's supposed to be talking. This is talking on a hands-free cell phone distract drivers. Undergraduate students drove in a high-fidelity driving simulator equipped with a hands-free cell phone. The car had brakes. How quickly does the subject respond? 40 students participated in the study. So this is studies that have actually happened, and I know I've seen certain videos of how I think actually Oprah did uh, something on this when it was coming out that talking on your cell phone was really actually distracting. And so here they're talking about, is it still distracting to talk on a hands-free cell phone? Which it is, hopefully. I mean, many of you I know have heard that you shouldn't be talking on the cell phone, and it's against the law now. But texting while driving, all those types of things, it's so distracting. It's been rated as an even higher than drunk driving when you're on your cell phone. So be very, very careful with not doing that. Okay, so that's my little plug for that. All right, so what are the factors? Okay. So here, what are we looking into? How are we going to break up people into different categories? And this is cell phone use. Okay, whether or not they're going to be on the cell phone. And then how are we going to break down cell phone use? Just what I said, there's going to be two levels. Okay, they're not on the cell phone, so no cell phone use. Or they're going to be on the cell phone, so on the hands-free device. And we're going to look at their response time is what we're going to measure. So outline a completely randomized design. So sometimes I'm going to draw this out as a diagram. You can also write this in a paragraph. You're not required to draw a diagram. You should still have all of the important key factors in it, but you are not required to actually draw this. You could write it in a paragraph if you'd rather. Okay. So it says we have 40 students who participated in the study, so we're going to take all 40 students. And we are going to assign them. We have two treatments, basically two levels. They're either going to be in group 1 or treatment 1, however you want to write this. So their treatment is, we can say, no cell phone. And the other group would be their treatment is they are on the cell phone. Okay, so treatment 1, they're just driving with no cell phone, and we're looking at their response times. Here, they're driving cell phone with driving. Okay, so we're not just looking at cell phone, we're looking at the reaction times. An important thing, one of our main things that we want to do is we want to randomly assign them to a group 1 or group 2. And we have lots of different ways that we can assign them randomly, but to show that we're going to do this randomly, you can put a little R over these arrows, and that shows that you're assigning them randomly to group 1 and group 2. Okay, and after we've assigned them to the groups and they've carried out finding what we're looking at the reaction times, we would compare reaction times, or I guess really what we're looking at is time to brake, like how long did it take them to actually hit the brake pedals. There's lots of different things. We'll talk about how we're going to analyze that data next semester, but this would be something like looking at the mean, looking at the median to compare their reaction times.